Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases.
Welcome to episode 16. We'll cover questions 76 to 80 in this episode. For questions 1 to 75, please refer to previous episodes of this series. Let's get started.
Question number 76. A business is considering migrating a classic application to AWS. Currently, the application communicates with an on-premises storage system through NFS. The program cannot be changed to perform this function using any other communication protocol than NFS. Which storage solution, if any, should a solution architect propose for post-migration use? So let's understand the problem. Also understand the keywords that are important here. So the scenario here is there is a business and it's migrating its workload to AWS. And in the current scenario on-prem, the communication protocol that it is using to talk to storage system is NFS. And they don't want to change this protocol. So when you move to AWS, the protocol should be NFS. That means the storage that you will use should be capable of supporting NFS protocol. And that's the key here. And if you scan through all the options and if you know the services well, you know that EFS is the protocol that will support NFS, others won't. So that is going to be your answer, option C. But we will go through all the options and eliminate the wrong ones. First option here is AWS Data Sync. Now, Data Sync is a data transfer service. It simplifies moving of large amount of data when you are moving from, say, on-prem to AWS. But it is not a service to be used in this case. It doesn't have NFS capability, so that is ruled out. The second one wrong, that is Amazon Elastic Block Store. Now, Block Store is a block level storage that you can use with EC2 instances, and it definitely doesn't support NFS protocol. So EBS is also wrong. The last in the list, which is option D, Amazon EMR file system. It is a deployment option for Hadoop distributed file system, which is used in Amazon EMR clusters. So it is not designed for general purpose file storage or NFS access. It's a very specific kind of a storage which is used in Hadoop distributed file system. And it definitely doesn't support NFS. So it is not suitable for this problem scenario for sure. So we rule out option D as well. That leaves us with the right option that we have for this scenario, which is Amazon Elastic File System. Option C is the correct answer for this particular question. Amazon EFS is a fully managed scalable file system that you can use with AWS services and on-premises resources. It supports NFS protocol, and that makes it as the correct option for this particular scenario. That's it on this question. Let's move on to the next question. Question number 77. A business wishes to run its mission critical apps in container in order to fulfill scalability and availability requirements. The corporation would rather concentrate on key application maintenance. The firm does not want to be responsible for provisioning and maintaining the containerized workloads underlying infrastructure. What actions should a solution architect take to ensure that these criteria are met? So let's understand an overall problem description here as well as highlight the keywords that are important. So what we have here, there is a business. It wants to run its applications in a container in order to fulfill scalability and availability. It's not clear here whether it is a migration scenario. It looks like the business is already in AWS, but the applications are right now not in containers, so they want to move it in containers. And the reason for that is they want to concentrate on key application maintenance. They do not want to be responsible for infrastructure management for these containers. So they want a suitable solution. Now, if you have done similar sort of services, you know that if you want a fully managed serverless solution for using containers, you should go for Amazon Elastic Container Service with AWS Fargate as the instance type. And that's your answer for this particular question, which is option C. However, we will go through each of the options and figure out why they are the wrong options and why option C is correct. So the first one wrong for me is option A. It says let's use Amazon EC2 instances. Now, EC2 instances means you have to manage the infrastructure. It is not a managed service, and you are responsible for patching, installation, updates, security patches, everything around infrastructure management. So absolutely wrong option. If the business select this option, they'll be spending all of the time to manage the infrastructure and they will have no time to spend on the application maintenance. It's a wrong option. Let's remove it. Second wrong for me is option B. Now this one also says, okay, let's use ECS. So you use container, but it is on Amazon EC2 worker node. That means you will have to manage the underlying infrastructure for EC2, which means it is an incorrect option. Similar to option A, the firm will end up managing underlying infrastructure. So wrong option. Let's go to option D. That appears to be incorrect as well. Now, option D says let's use EC2 and ECS. So similar to option B, but then create those EC2 instances using AMIs, Amazon Machine Image, which means the creation of EC2 instances will become simpler because you are using AMI templates, but it is still at the end of the day EC2. That means you have to manage the infrastructure and it will end up like option B. So option A, B, and D are incorrect. What we are left with, option C, is the correct answer, which is you will use Amazon ECS, which is the container service, and you will use AWS Fargate as the instance type. AWS Fargate is a fully managed serverless instance type, and that is the best solution when you are going for a containerized solution. We will do a deep dive on how good the services or the solution is, and we will match all the requirements that were mentioned in the problem with what we get from the solution. So the first one, which was mentioned, is manage infrastructure. Now, with this solution, which is ECS and Fargate instance type, AWS manages complete underlying infrastructure, reducing operational overhead. The second requirement was scalability. The business wants scalable and highly available solution. So in terms of scalability, Fargate automatically scales container resources based on needs. So you don't have to manage any scaling, or you don't have to support it using auto scaling. It is having that built-in capability. The third one, the business wanted to focus on application. He doesn't want to do anything with infrastructure management, and you get that output from this particular solution because company now can focus on their core application developing and maintenance rather than worrying about the infrastructure. Because the overall solution that we have is a fully managed service, and AWS will manage everything without business worrying about anything for the infrastructure management or maintenance. The last one is high availability, and Fargate make sure that the containers are launched into multiple availability zones. And that's important here. Multiple availability zones. That means if one of the availability zone goes down, you still have your Fargate service running, and overall solution thus becomes fault tolerant, and it gives high availability by doing this. So that's overall recap of the chosen solution. That's it on this question. Let's move on to the next question. Question number 78. A business operates a service that generates event data. The firm wishes to use AWS for the purpose of processing event data as it is received. The data is structured in a certain sequence that must be preserved during processing. The firm wishes to deploy a solution with the lowest possible operating cost. How is this to be accomplished by a solution architect? So let's understand the problem and highlight the keywords here. So what we have here is we have a business that is having a service that generates event data, some sort of event data. We are not sure what exactly it could be. It could be maybe IoT devices which is generating event data. And the job for the firm is to process that event data as it is received. Data in this event is structured and it has certain sequence. This is a very important requirement that we need to preserve the sequence. The firm wishes to deploy a solution that with the lowest operating cost. So we don't want to spend a lot of money for achieving this. So what solution we will use? Now, if you have done similar sorts of problem, whenever you have to process messages and you have to guarantee sequence, definite answer is AWS SQS. And you can see option A and option C has that service over there, and option B and D have SNS. So SNS is definitely wrong. So our option is going to be one from A and C. And because the sequence is important, it is going to be first in, first out queue. So SQS with FIFO queue is going to be the answer for this, which is option A here. But we will go through other options. We'll eliminate those and we'll come back to our main option again. So the first one wrong, the first SNS, which is option B. Why it is wrong is, I think Lambda is all right. You can put Lambda as a processing unit, but having SNS is incorrect. As I told you, SNS is not used for the scenario that we have mentioned here. It is a publisher subscriber messaging service. Is suited for fan out scenarios where a message needs to go to multiple consumers, and that's about it. It cannot be used for the requirement that we have here. So we will rule it out. Option D also uses SNS, but it is using SQS as a subscriber. So this is completely incorrect option because SNS is first of all wrong. Then you are using SQS. I don't know how it's going to work. Plus, there is nothing to process the data. There is no compute resource here. There needs to be a Lambda or something else to process it. But this is a very incorrect option. and we will rule it out. So we are left with option A and B, both uses SQSQ. So they are at least on the right direction. But if you see option C, it is having an SQSQ. It will hold the messages. It would deliver it to AWS Lambda, but it's not going to guarantee the message order because there is no configuration done for this queue to preserve the order. So standard SQSQ won't work. That's incorrect. It will not guarantee the sequence. So that leaves us with option A, which is the perfect solution here. The SQS, which is configured as a FIFA queue, and it will feed AWS Lambda, and AWS Lambda will process the messages from the queue, and that would achieve the overall solution. Let's do a deep dive here in terms of how this option A is suitable and how it matches the requirements. So first of all, answer for this question is option A, SQS FIFA queue to hold the messages plus AWS Lambda to process the messages. In terms of the characteristics which makes this option suitable is, first of all, it's very cost effective. We are using Lambda function here, which is serverless, and it is built per execution. Reduces the cost as compared to constantly running services. If you imagine like an EC2 or some other compute service, which is held forever, irrespective of whether there is data there to process or not, because FIFO itself is a very cost efficient solution for sorting out ordered message queuing. So that's cost effectiveness. The second one is order processing. Obviously, FIFO queue ensures that the messages are processed in an orderly manner. Scalability is the third benefit of this solution. SQS and Lambda, they both scale automatically. So if you're getting more data, SQS will scale up. If you're getting less data, SQS will scale down. Similarly, depending on how many messages are arriving, Lambda will automatically scale and handle the fluctuation in message volume. So it's a very scalable solution. And that's why this overall solution becomes a appropriate one for the given problem scenario. That's it on this question. Let's move on to the next question.
Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you've not already done it. Thank you.
Question number 79. The database of a business is hosted in US East 1 region on an Amazon Aurora MySQL DB cluster. The database is around 4 terabytes in size. The company's disaster recovery plan should be expanded to include US West 2 region. The firm must be able to fail over to US West 2 within 15 minutes of recovery time goal. What recommendations should a solution architect make to satisfy these requirements? So this is a very lengthy question with options also very lengthy. So I will just use question here to highlight keywords. So the keywords here are, we have a business which is hosted in one region, in this case, East 1, and is having a Amazon Aurora MySQL DB cluster. It is quite huge. It's 4 terabytes in size, and we want a disaster recovery solution. The plan should be expanded to include West 2 region. And overall, what we want is the failover time. The recovery time goal for failover should be 15 minutes. Now, if we have to choose a solution for this, that means we have to select a database which has this RTO inbuilt in it. And that's what is the crux of the problem. And I'll show you an article from AWS. So this is an article from AWS which talks about switchover or failover in Amazon Aurora Global Database. And if you zoom in on recovery time objective, which is the time taken for system to return back to its working state after a disaster or a recovery or a service outage has happened, is in case of Aurora Global Database in the order of minutes. So this is the key for answering this question. You need to know the RTO objective for Aurora is in minutes, and that's the answer for this question. We'll go back to our options and then evaluate and see, first of all, if this particular answer is in the given options, and we will also eliminate the other incorrect options. So we can see option D is the one which is having Aurora Global Database. So that answer does exist here, but we'll go through each of the options and see why they are not suitable. So first one is multi-region Aurora MySQL DB in US East 1 and US West 2. Then using an Amazon Route 53 health check to monitor East 1 and failover to West 2 upon failure. It's not suitable because Aurora multi-region cluster are designed for low latency read replicas. It's not used for disaster recovery purposes. So you can use this solution if you want a replica solution and you want multi-region for obviously availability situation, and you want to do it for low latency read replicas, but not for disaster recovery. So option A is incorrect. The option B says let's take a snapshot of DB cluster in East 1, then configure an event bridge that will invoke AWS Lambda function upon receipt of resources events, then configure Lambda function to copy the snapshot from EOS2 and restore the snapshot in WAS2. So this whole take snapshot, restore a 4 terabyte database is not going to be 15 minutes. It will be significant time. It will be hours. It could be days as well. So this is not going to be correct. So we rule A and B both out now. Then we have option C, which says let's create CloudFormation script to create another Aurora MySQL DB cluster in WAS2 in case of failure. Configure an event bridge that will invoke Lambda function upon receipt of resource events and Lambda function to deploy AWS CloudFormation stack in US2 when failure is detected. So this one says when failure happens, let's create the whole stack again in another region. Use CloudFormation stack so it will make it quicker. According to me, this solution is not going to work. Theoretically, it is possible, and one can say it could potentially meet RTO requirement, but it's such a complex solution. And to be honest, I don't believe it will meet 15 minutes RTO, and I don't have an evidence for it. So option C is also ruled out. And as I've already told you, the way you should select answer for a particular scenario is you need to select where possible a single service, a service which is purpose built for the given problem. You need to take a you need to select a fully managed service, and that is how you would be able to solve this. Now let's see what does option D says, which involves Aurora Global Database, and that is the key here because it's a global database that comes up with the 15 minutes RTO. So let's see how this option is going to work. So it says let's recreate as an Aurora Global Database now itself, not after disaster, and with primary DB cluster in East 1 region and secondary DB cluster in West 2 region. Then you configure an Amazon Event Bridge rule that invokes AWS Lambda function upon receipt of resource events. Configure the Lambda function to promote the DB cluster in West 2 when failure is detected. So in this scenario, what you have is you have your database ready in both East 1 as well as West 2. And what your event bridge or the CloudWatch event rule is doing is it is informing Lambda that a disaster has occurred and now West 2 needs to be primary DB cluster. And that's what it is doing. It's not doing the creation of the overall database that is in the option C. And this will definitely give you the RTO of 15 minutes. And this is the perfect solution. We've gone through this article and I'll give you the link for all of this in video description. But from an exam perspective, this is what you need to remember. Aurora Global Database has recovery time objective of minutes. So that'll be your choice where you have a scenario involving Aurora database or you need a multi-region recovery time objective of order of minutes. So option D is the answer for this particular question. As we discussed earlier, Aurora Global DB is the solution for this. That's it on this question. Let's move on to the next question. Question number 80. A business is installing an application that handles near real-time streaming data. The workload will be run on Amazon EC2 instances. The network architecture must be configured in such a way that the latency between nodes is minimal as feasible. Which network solution combination will suit this requirement? You have to select two options. So what do we have here is we have a business and it has an application that handles near real-time streaming data. And that's your keyword, near real-time streaming data. The workload will run on EC2 instances. So you have EC2 instances in the solution. And what you need to do is you need to configure the network such that latency between nodes is minimal as feasible. And this is choosing to, so obviously you are trying to do multiple things here in order to achieve the outcome. Let's go one by one and figure out what options are correct. Now, I would like to eliminate first. So option B says group the EC2 instances in separate accounts. Now, if you group the instances in separate accounts, it will increase the network complexity and definitely will not reduce the latency between the instances. So grouping of EC2 instances is not going to help at all. So we rule that out. The next one incorrect to me in the list is, so option D says, let's attach multiple elastic network interface to each EC2 instance. Network interfaces, which is ENIs, can provide some additional bandwidth, but it doesn't do anything to improve latency between network instances. So this is not going to be a solution for improving the network latency. So we rule that out. Option E as well, it says, let's use EBS, optimize instant type. Now, that will give you high performance storage, but it will not directly address the network latency. If you want to improve network, why would you invest in compute? So it's going to be a wrong solution altogether. So option E is gone. That leaves us with two options. And let's see. I'm still not 100% sure about the correct answer here. Let's see what we have in option A. So option A says enable and configure enhanced networking on each EC2 instance. I think this will work. Enabling enhanced networking on EC2 instance will definitely improve network performance by optimizing communication between instances within a single availability zone. So this will help with all the instances which are in the single zone. So this will be helpful in this particular solution, but obviously this is not alone going to be sufficient. Let's see what we have in option C. Run the EC2 instances in a cluster placement group. Yeah, this would definitely help, because if you have EC2 instances on specific hardware within a region, ensuring they are physically near each other, that means you will have potentially lower network latency between instances as compared to having random EC2 instance placement. So this will work. Overall, there is not much logic here, or a rule that you can follow, or this is not a theme-based question as well. Uh, this looks like a one-off, but if you logically eliminate it, then you should be able to get to the correct answer. So for me, option A, which is enabling enhanced networking on instances and then placing two instances in a cluster placement group, appears to be a correct combination of the steps that would improve the network performance and the latency. So that's our answer, A and C. And I believe that was the last question in this particular episode. I'll see you in the next episode of this series soon. Thank you. This is Exam Tricks and Tips. You're watching the AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.